play with the MATLAB in order to understand how things work. Let's have an example. A canned juice company creates an under the caps promotion. تفتح الغطاء يطلع لك ريال أو يطلع لك إنك لك هدية ريال أو لا. Whereby the customer can win an instant cash prize of 1 real by looking under the bottle cap with a probability of 0.25, sorry, 1/4. يعني probability that when you open the can and you see 1 real under the bottle cap, have a probability of 0.25, 1/4. كريمة الشركة. A customer buys 8 bottles of juice. أول شيء find the PDF or the PMF. احنا نسينا يمكن نتكلم عن الكلمة PMF. تذكروا probability density function PDF. خليني أرجع على الدرس هذاك لأنه this is important to put it as a note. probability density function لو تذكروا كنا نقول عنها PDF, right? probability density function. in case of in the case of discrete random variable, sorry. In the case of discrete random variables, الPDF شكلها كيف قلنا احنا؟ It's a series of deltas, right? جاتكم السلايد حقت density function؟
Yes, we do see.
ممتاز. لو تتذكروا احنا قلنا it's a series of deltas, right? عشان كذا in many textbooks you can find it that for discrete random variables in general, PDF is referred to as PMF. ايش يعني PMF؟ probability mass function. And this is well known in many textbooks, PMF. Okay, why? Because it's a series of deltas and شكلها كذا كأنها توريك كيف الماس أو total mass of probability of equal 1, how is it distributed among the different values of x. So this is a well-known name, just for your information. So when you hear the word BMF, means the PDF of a discrete random variable. This is what it means. طيب. So the question was, find the PMF or the PDF of the number of winning bottles. Winning معناها اللي يطلع فيها تحت غطاها ريال. Donated as X. So this is basically the random variable. And compute the probability of winning more than 4 reals. فالrandom variable X has what? Has n equal 8 لأنه الرجال هذا اشترى 8 bottles, right? And P equals 1/4. This is the first step to identify the parameters of the random variable. Step number 1. Identify the parameters. طبعا أول شيء, in general, you need to understand the problem هذه can be solved by which random variable. So step number 1, kind of random variable. Step number 2 is identify random variable parameters. إذا هو Gaussian, you need to identify what? The average with standard deviation. إذا binomial, you need to identify n and p, right? And then solve. هذه دائما steps of solving. Okay? So for the random variable here, we understand that it's either there is a 1 real or no 1 real. So it's basically a Bernoulli trial. We repeated 8 times because he bought 8 bottles. So n equal 8. and the probability of having 1 real under the bottle cover is 1/4. And because of that, it's a binomial. We know that the PDF looks like this. The PDF looks like this. It's a series of deltas, each weighted by the probability of x equal k. And the probability of x equal k is defined as this. Probability x equal k. For short, we write it as px of k. It's k choose k, sorry, 8 choose k, 1/4 to the power k, 3/4 to the power 8 is 8 minus k. And for short, it comes to this after simplification. واضح؟ Now the probability of winning more than 4 real is equal to the probability of x larger than, strictly larger than 4 real, k equal 4. Right? Which is the summation from k equal 5 to 8 of 8 choose k and then this number, which is probability, each one of them is the probability that x equal k. واضح يا شباب؟
Yes.
طيب, I need you to send me over the private chat. What is the probability of not winning anything? Not winning any real. احسبوها وارسلوا لي اياها بالبرايفت chat. The probability that you don't win anything. تشتري ثمن علب على الفاضي. Anything. يا شباب send please. Calculate and send. شباب في بعض المرات اشوف شات وانا في نص الكلاس او نهايه الكلاس انه واحد يسال can you record please. شباب انا I'm leaving this to you. Please start recording. I always forget to record. Any one of you please start recording if you don't see it recorded. I have seen it several times until now. طيب what is the probability of yes كيف نحل يا شباب؟
Is when k equal to 0?
Yes, it's a probability that k equals x equal 0. تمام. What is the probability of x equals 0? It's n choose 0, p which is 1/4 to the power 0, and then 3/4 to the power كم؟ احنا قلنا n هي 8 already. We know what n is. 8 choose 0. And then 3/4 to the power 8. So basically this is equal to 1 and this is equal to 1. It's 3/4 to the power 8. أحد يقدر يحسبها بالكالكوليتر شباب؟ 0.75 to the power 8.
0.1
0.1 بالضبط. طيب ممتاز. And the PMF looks like this. Okay, so if you would like to visualize how does the probability change with K, you can see that this is as K changes, increases, you can see that the probability of winning more and more becomes 0. Why is that? Because the probability is small, it's 0.25. The P is 0.25. So usually it peaks at NP, which is 8 multiplied by 1/4. It's كام؟ 2. البيك عادة at NP. The peak. the peak of the distribution عادة at NP, at K equal NP. And then it dies off. واضح شباب؟ الآن if P was 0.5 sorry كانت نص، كيف شكل هذا يصير برأيكم؟
peak at 4.
It will peak at 4 لكن مو بس كذا. It will be symmetric، حيصير شكلها كأنها سوري هذه 0 وهذه 8. So it will be like this, 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 this. يعني حيصير السنتر حتصير basically symmetric. If P equal 0.5. واضح؟ طيب. Now the second أي سؤال على binomial before we go؟ طيب the second random variable that is very important and you see it in many physical problems, especially networking problems for the electrical engineering, is the Poisson random variable. Poisson random variable is the limiting distribution of the binomial. هم لهم علاقة كالتالي. If we have a binomial, well, binomial as n goes to infinity and p goes to 0. بمعنى انك you are repeating the experiment many times with the probability of success approaching 0 while you are keeping np constant. np equals b, a constant b. Then the binomial discrete distribution approaches what we call the Poisson distribution. Okay, it approaches the Poisson distribution. And the Poisson has a PDF that looks like this. It's a series of deltas, okay, with the probability that x equals k equals e to minus b, b to the power k divided by k factorial. Okay, so it's a series of deltas that has the amplitudes of the deltas given by probability of x equal k. And hence the CDF will look like a series of step functions. And you can see, for example, here, this is not clear. This is for b equal 1, b equal 4, b equals 10. If b equal 1, means that it's highly unlikely that this will not happen, that this random variable will not happen. And because of that, you can see the peak is around very small values because b equal 1. This is b equal 1. While this is b equal 4, you can see that it is more distributed and the peak around 4. While this is b equal 10, and you can see that it's much wider and the peak is around b, which is 10. Basically, when we go to the chapter 3, we will find that the average of this is b, the average, the mean. Similarly, the CDF, you can see that it's step functions, and this is again for the same b equal 1. You can see that it goes to 1 very quickly, and this is b equal 4, and this is b equal 10. Okay. So when do we apply Poisson distribution? It applies to them, as we mentioned, to very wide variety of counting applications. بمعنى, the number, if I ask you the number of defective units in a production line, الناس اللي يشتغلوا في industrial engineering, البويسون distribution هذا مثل ABC بالنسبة لهم. This is very important distribution for those who work in manufacturing or logistics or supply chain and so on. The number of defective units in a production line. The number of, في networking, electrical engineering, the number of telephone calls made in a specific period of time. The number of packets arriving to a router in a specific time. The number of electrons emitted from a small section of a cathode in a given time interval for the physics, and so on. So it applies whenever I give you a time and I ask you for the number of events in that time. Okay, then a time period, and I ask you for the number of events in that time period, or that production line, or whatever. So the way we count is we calculate, or we define the time interval of interest. We call it capital T. And we define the average arrival rate, which is lambda. The average arrival rate per unit time, per second method. Then the number of arrivals will have an average of B equals lambda T. Okay? And the way we calculate it as this PDF, and this is the CDF. زي ما قلنا, PDF is based on the fact that probability that X equal K equals A to minus B, B to K divided by K factorial. This is the way we calculate it. So again, if I give you any problem, simply you need to understand first of all which random variable to apply, and then you need to find the parameters. In this case, what is B? We only have one parameter, and then we calculate. Simple. Any questions about Poisson distribution? We'll take examples, but any question about the concept here? واضح؟
دكتور
تفضل.
الحين نستخدم البايثون distribution whenever we given a period of time and we want the trials on that period, right?
Yeah, the number of arrivals, the number of defective, and so on. Yes. Yes. When we have a rate of happening and a specific time, a rate of happening. يعني مثلا أقول لك إنه telephone calls arrive at a rate of 10 calls per minute. And المقسم هذاك مثلا حق it can only hold for, it can only accommodate 5 calls at a time. Okay? What is the probability that I have blocked calls مثلا؟
طيب دكتور
هنيجي على بعض الأمثلة. تفضل.
السلايد اللي قبله فيه n goes to infinity and the probability goes to 0.
هذا mathematically how is this Poisson related to the binomial? Mathematically, how are they related? Simply, Poisson is the limiting behavior of the binomial. When n goes to infinity and at the same time p goes to 0, with the probability that with the np being constant.
Thank you.
تمام؟ يعني هي كالتالي. انت يعني طبعا I don't want to go into the details of this لانه فيها a lot of math. لكن تفهمها كالتالي. Let me take it on the side. إذا أنا عندي long period of time from 0 to capital T. Okay? Now I can divide this into كم؟ 6 period. تمام؟ وأنا أقول إنه حيصير في هنا event. The probability that event will happen P or 1 minus P في كل واحدة. تمام؟ An event will happen, an arrival will come, a call will come to the access point, and so on. خلاص؟ الآن I can calculate everything here using binomial. تمام؟ However, this is very limiting because in many cases you don't really have a specific division of the time. فاللي يصير if I zoom in أكثر، إذا أنا قسمت الوقت أقل بكثير، بدل ما يكون كل واحدة 1 second, no, I go to the millisecond, to the microsecond. And P لأنه طبعا صغرت الوقت فال probability of happening becomes smaller and smaller. So P approaches 0 and N approaches infinity. بينما ال product NP is the same. ال average of arrival ما تغير. ال average of arrival في T هذه كلها هو نفسه. أنا قسمت الفترة هذه على 6 ولا على 600,000 ولا على 6 مليون جزء. ال NP is the same. صح ولا لا؟
ايوه صح.
تمام؟ فالفكرة الآن إنه if I do this, I don't, in this case, I'm not looking at the discrete time behavior rather than I'm looking at a continuous time behavior. أنا الآن عندي from 0 to capital T. أنا ما قسمت شيء. What will be the probability that I have K arrivals in this long period? بدل ما أقول لا أنا أقسمها لأجزاء، ما أبغى أقسمها أجزاء. I take into infinity. إذا أخذت into infinity, the probability of an event to happen في 1 microsecond is very small. It goes to 0. However, NP اللي هو average rate of arrival is the same, is equal to B. So the Poisson solves for me the problem that basically of this sort. إذا عندي أنا وقت معين كم arrival, what is the probability of K arrivals in this number? And it can take ما توصل إلى N equals 6. And I'm not limited here to 6 arrivals. It can go to infinity arrivals. صح ولا لا؟
ايوه صح.
إذا قسمتها 6 أنا I'm limiting myself to 6 arrivals. However, it might have more than 6 arrivals in general. فهذه الفكرة كلها. طبعا فيها a lot of math how to go from this to that, لكن this is beyond this course. لكن أنا ودي إياكم تفهموا فكرة العلاقة بينهم. أوكي شباب؟ أي سؤال؟ طيب let's have an example. A gasoline station. We have cars arriving according to Poisson distribution at a rate of 50 per hour, 50 cars per hour. There is one gasoline pump only. خلاص؟ يعني number of servers is 1. And it takes 1 minute to obtain the fuel. هنا السؤال, what is the probability that I have a waiting line? أول شيء هو كريم في السؤال حدد لي distribution. فstep number 1 done. Poisson. Step number 2, I need to find the parameters of Poisson. إيش البارامترز حقت Poisson؟ شباب.
Delta and B.
Yeah, delta and T اللي هي تعطيني B. Basically الشيء المهم بالنسبة لي is B. Poisson has only one single parameter which is B. B يعتمد على الدلتا والتي. If I have delta and T, so B which is from delta and T. Once I have delta and T, lambda and T, I can get B. So what is lambda and T? قال لي إنه the arrival rate is 50 cars per hour. So it's 50 divided by 60 per minute. And the waiting time is 1 minute. Our service time. So B multiplied by, lambda multiplied by T gives you 1 minute by 50 over 60 gives you 5 over 6. Now the question here is, what is the probability of a line to occur? When does a line happen? Waiting line. ايش رايكم؟
When we have more than one customer.
More than one customer. More than, strictly more than. So this is equal to the probability that X is strictly larger than 1. صح؟ طيب strictly larger than 1 means what? Means the summation from I equal 2 to infinity. لأنه أنا عندي البويسون فيها infinity ما فيها up to n of e to minus b, b to k, I والله هذه كتبناها, and I factorial. صح؟ However, this is extremely difficult to calculate لأنه it's up to infinity. عندي infinite summation. لكن I know إنه this is equal to 1 minus the probability that x is less than or equal to 1. صح ولا لا؟
يا دكتور.
Which is 1 minus f of 1. And I know that f of 1 or the probability that x sorry, the 1 minus probability of x less than or equal to 1 equals 1 minus the probability that x equal 1 minus the probability that x equal 0. I have only two things to calculate. أول واحدة equal طبعا عندي e2 minus b common factor x equal 1 I have b to 1 divided by 1 factorial plus b to 0 divided by 0 factorial. This is equal to 1. Okay, and this is equal to b, which is 5 over 6. And this gives me this solution, 0.2032 or 20%. So the probability in this gas station to have a waiting line is 1/5 of the time. يعني إذا أنت دائما تمر عليها وأنت رايح البيت خمس المرات اللي تمر عليها تقريبا you will find somebody is waiting 20% of the time. This is the way we read it physically. This is the way we read the answer. طيب يا شباب, do you know how to calculate this? How did we do it?
Yes, doctor.
Or you can ask any question here. Yeah, this is one example. You can have any question. You can say, what is the probability that I come and I find the gas station empty? Probability of gas station empty. ايش رايكم؟ ايش هذه؟ ما في احد يعني.
It will be 1 minus e to the power minus 5 over 6.
ليش؟ لا قبل ما نروح للكالكوليشن what is this equal to probability of what يا شباب قبل ما before you jump into calculation write what is this probability in math
X equal to 0.
x equal to 0 ممتاز and what is this equal to what is this equal to
1 over 6
e minus b اللي هي 5 over 6 multiplied by 1 اللي هو b to the 0 divided by 0 factorial which is 1 so it's e to minus 5 over 6 أحد يقدر يحسبها بس عشان نعرف إيش probability إنك تحصل ما في أحد
0.435.
Oh, so it's 40% of the time 43% of the time you'll find nobody there ممتاز اوكي يعني اذا انت تمر عليها في رايح من الشغل 40% او 43% you will find nobody there which is nice يعني بالنسبه لك it's good to fill in طيب
دكتور
تفضل
from this I can say that the possibility to find a line it go from 0.5 and less even if I find one in the line in the line.
Hey, this is equal to 1 minus probability that x is larger than or equal to 1. Yes. اللي هي the probability that you find one or more. 1 minus that. Yes.
I got it.
تمام. Did I answer your question?
Yes, doctor.
ممتاز. طيب. Another practice example. Packets arrive to an internet router at a rate of 20 packets per minute. And the router needs 3 seconds to process them, to process each one. Okay? If the router can serve 4 packets at a time, this is the capacity of the router. Find the probability that new incoming calls or packets will not be served. Packets will not be served. فأول شيء whenever we find this the number of كذا in a specific time على طول نعرف إنه Poisson. Second step, identify parameters. We need to find B, and then one parameter only. To find B, I need lambda from lambda and T, right? So let's see, what is lambda here? Arrive at 20 packets per minute. So in every minute, you have 20 packets. So this is lambda. And it needs 3 seconds to be served. So I have T equal 3 seconds. And عندي minute to second. I need to يا لازم اشتغل يا بهذه ما ينفع. أحول السكند إلى minute أو أحول المينت إلى second. So let's work with the second. So B will be lambda T. Lambda here is 20 packets per minute multiplied by 1 minute per every second, 60 seconds. Minute cancel minute. So we have 20 over 60 second per second. Multiplied by 3 seconds, I get 1. So B here, the average arrival rate is B. The average arrival, so the average is B, is 1. Now, here this gives me the probability that ايش السؤال كان؟ No, that new incoming calls will not be served. What is this probability? نترجمها ل X. Probability of what?
X greater than 4.
X is larger than, strictly larger than 4. ليش؟ لأنه الراوتر has 4 packets at a time capacity, which is equal to 1 minus probability that X is less than or equal to 4. Right? Which is equal to 1 minus summation from K equals 0 to 4, the probability that X equal to 4. ممكن نكتبها. Which is E2 minus 1 multiplied by B اللي هو 1 to the power K divided by K factorial. Every one of this is probability of X equal K. وهذا السوليوشن عندكم يطلع الآن final answer equal 3.66 to the power minus 10 to minus 3. Any question? شباب؟
Doctor, here we avoid the infinite sum by finding the probability of not.
Exactly. Always you have to do it this way. Otherwise, you will keep calculating for infinity. It's impossible. So you always have to work it this way. تمام؟ ونفس الشيء في الباينوميال by the way. الباينوميال لما يكون n equal 5 ولا 3 and so on مو مشكلة بسيطة. I can calculate it either way. لكن لما يكون n equal 1000 وأنا أطلب probability that x is larger than 5. Can you calculate from 6 to 1000? Always go to the opposite. 1 minus probability that x is less than or equal 4. صح ولا لا؟
Yes,
okay.
Of course. Easy.
Now this is the same. طيب, time is up. So if you have any question, please do ask. And anybody would like to leave, he is free to leave. طيب, أي سؤال يا شباب؟ So next time, inshallah, we'll go with the uniform and the other continuous type. Any question? Okay, so we'll see you inshallah next Sunday. Assalamu alaikum.